So here today we have a setup of HDMI extender over 60 gigahertz over WiGig. So this is the kind of the main transmitter, and over there we have a receiver at the TV screen. And we're going to use the SAF Tehnika V-band spectrum analyzer, a compact one, to measure beamforming, power and band. Essentially, currently that for us is a black box with no specifications available out there. So we'll try to detect what is it actually doing, what is the power that is emitting at this location, or it could be any other location. And we'll try to look at several trace modes as backhaul, cumulative, and see how it behaves in different polarizations. So here we have a tripod where we can mount the unit to. And first we're gonna look at the full span to see is it transmitting at all anything and at what frequency is it transmitting. So for the measurement here, we have a fixed small antenna which is good enough for this small distance. And we can set it up for measuring power in band, so integral power under the channel bandwidth. We know that for WiGig, the channel bandwidth is 2.19 gigahertz. So we can set it up here on the frequency on the center frequency that we are measuring, and measure that currently we are seeing a good received signal. And when we do the alignment, we can see how the signal goes up and down, and how the actual measurement differs from the backhaul feature that we have here. The system here shows what is the measured signal at the current location and what was the maximum power and band measurement at the maximum peak of the transmitted signal. Similarly, by changing, we can change, of course, not only angles, but we can easily move around the room and analyze the environment that currently the unit is being transmitting. So that will also allow you to characterize and see is the beamforming working or not. So you will see, does it have the direct beam to the receiver, or is it using some reflections, or is it enabling more transmitters, or what is it actually doing there? Besides power and band, we can check also polarization. So for example, with this tripod, or you can hold it on the hand, we can rotate the polarization, and we can see that for this particular equipment, the measurements on the horizontal polarization drop dramatically. So we see that it is actually mainly using the vertical polarization instead of the horizontal polarization. Any measurement you're doing here, you can actually save it, the single scan, or you can record entire measurement process. So for example, in the measurement process, you can decide you want to add attenuation in between the transmitter or receiver, or you can rotate the transmitter to see how the beamforming operates, or you can move the spectrum analyzer itself around the unit under test to see how the power is received in that environment. Is it reflective? Is it direct? And what is the power measurements in each location? After you've done all the measurements, either in the scans or the recording mode, you can post-process in the included software and do all the same operations as on the unit itself. So you can do power and band, you can add markers, you can change the trace mode, you can zoom in, zoom out by changing the span. And all those measurements you can easily add to the reporting tool, which is also included in the software, and start building a very simple report of your measurements. Thank you for watching. Bye.